Chapter 10.6, find segment lengths in circles. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. All right, so it says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. All right, so pretty simple. A chord is a segment whose endpoints are on the circle. So we have two chords and they intersect inside the circle. All right, so we have EA times EB. That's going to be this times this, and that equals EC times ED. That's going to be this times that. Pretty simple. Example 1, find ML and JK. All right, we said it a minute ago, when you have two chords that intersect inside the circle, the product of their segments are equal. So we have X times X plus 4. I'm going to write it down here. You know, before I get into the variables, I'll just write the segments first. All right, so this right here is Kn times this right here, Nj. All right, so we have Kn times Nj. And the other chord is going to be Mn times Nl. Mn times Nl. All right, now we can plug in Kn is just X. Nj is X plus 4. All right, use parentheses because it's multiplied by the whole quantity. Mn is this segment, that's X plus 2. Use parentheses. NL is this segment, that's X plus 1. All right, now we use FOIL or distribute. X times X is X squared. X times positive 4 is 4X. Distribute. X times X is X squared. X times positive 1 is 1X. Distribute. 2 times positive 2, positive X. 2 times 1. And there you go. I'm going to do two steps at once. We have an X squared on both sides. I'm going to get rid of that. The opposite of positive X squared is negative X squared. X squared minus X squared cancels on both of them. Bring down your 4X. Bring down the equals. Combine 1X plus 2X. That's going to give us 3X. And bring down the positive 2. Solving for X, we want to get the X's on one side. So the opposite of positive 3X is negative 3X. Do that to both sides. 4 minus 3 is 1, and we still have the X. 1X is just X. 3 minus 3 is gone. Bring down the 2. That's it. So luckily the X squared dropped out. We didn't have to have a quadratic or a factor. Actually, they asked us to find ML and JK. All right, so we just have to take that 2 and plug it in. All right, they asked us ML. So if we put a 2 in there, because we said X equals 2, right? Yes. If we put a 2 in there, that's going to be 4. And if we put a 2 in there, that's going to be 2 plus 1 or 3. All right, so this is 4. This is 3. ML is the whole thing. So ML is just 4 plus 3, or 7. And then on the other one, I'm assuming they asked JK. All right, that's this whole thing. Plug it in. In place of X, that's just 2. And plug in a 2 right there. 2 plus 4 is just 6. So for JK, we have 2 plus 6. And that equals 8. Okay, the chords are not necessarily congruent. If they were both diameters, they would be congruent, but they're not. So that's why we got a different answer for each chord. Okay, a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant segment that is outside the circle is called an external segment. Okay, remember the secant line or secant segment in this case, it intersects the circle at 2 points. All right, so right there and right there are the 2 points. That's what makes it a secant. Okay, the part of the segment right here in red that is outside of the circle, that's called the external segment. All right, and this one here in blue, it's a segment just because it's not a line. It has 2 endpoints. But the thing that makes this one in blue tangent is because it intersects the circle at just 1 point. So that's a tangent segment. All right, if 2 secant segments share the same endpoint outside a circle, the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. All right, so these are both secant segments because they intersect the circle at 2 points, right there and right there. Okay, and this formula applies because the segments meet outside the circle at point E. So we have EA times EB, that's this times the entire segment, equals EC times ED. That's this times the entire segment. Okay, so when you have the 2 secants that meet outside the circle, you take the external segment and multiply it by the length of the whole segment. And that equals external segment times the length of the whole segment. Example 2, what is the value of X? By the way, I see one of my answers is a mixed number. Okay, so if I get a certain answer, I'm going to keep it as a fraction, not a decimal. All right, so we have 2 secant segments. They meet at point R. Let's use the 2 letters first for the equation. So we're going to have the external, that's RS, times the whole thing, that's RT. All right, so we have RS times RT. And now the other one, we have the external, which is RQ, times the whole thing, RP. Okay, RQ times RP. RS is this right here, that's a 3. RT is going to be the whole thing, so that's going to be X plus 3. So we need parentheses. X plus 3. RQ is this piece right here, that's just 4. And RP is going to be this whole thing, that's 5 plus 4. All right, you could write 9 if you want to, but I want to write all the little steps. All right, distributing 3 times X, it's 3X. 3 times 3 is 9. Keep the equal sign. 5 plus 4 is just 9. Okay, and then 4 times 9 is 36. Solving for x, we want the x's by themselves on one side. So get rid of the positive 9. The opposite is negative 9. 9 minus 9 cancels. Bring down 3x. Bring down the equals. 36 minus 9 is 27. And this is x times 3. The opposite of times 3 is divided by 3. 27 divided by 3 is just 9. And that is answer D. All right, please pause and try number 1. Use the same formula we just did. All right, we have two secant lines, or segments. I know they're secant because they intersect the circle at 2 points each. They meet at a point outside the circle, so we can apply the formula. Okay, there's no letters here, so we'll just go right into the numbers. The external segment is 6. And the entire segment is going to be 6 plus 9. And that equals the same on the other side. The external piece or segment is 5. And that's times the entire segment, which is going to be x plus 5. All right, use parentheses. All right, of course, 6 plus 9 is just 15. And 6 times 15 is going to give us 90. Distributing 5 times x and 5 times positive 5. All right, solving for x. Minus 25 on both sides. Cancels here. 90 minus 30 is 60, so this is going to be 65. Bring down your 5x. The opposite of x times 5 is divided by 5. Cancels here. 5 into 6 goes 1 time, carry the 1. 5 into 15 goes 3 times. So it's just 13. X equals 13. All right, please try number 2. So we have two chords here intersecting inside a circle. So we're just multiplying the segments, setting them equal. 4 times 6. And that's going to equal x times 3. All right, light work. The opposite of times 3 is divided by 3. Cancels here. And I always like to reduce fractions first. 6 divided by 3 is 2. And of course, 4 times 2 is 8. All right, please try number 3. This one is a challenge. I think you're either going to have to set it equal to 0 and factor, or use quadratic formula. Hopefully you can just factor it. All right, let's see here. External segment is 3. And the entire segment is going to be 3 plus x plus 2. And that's going to equal external segment, which is x plus 1. Use parentheses, and that's going to be times the entire segment, which is x plus 1 plus x minus 1. All right, so we have x plus 1 plus x minus 1. Really, I should use parentheses again. It's not going to matter, but like right here, we did 3 plus x plus 2. And then right here, we did x plus 1 plus x minus 1. All right, it's actually not going to make a difference, but just so it's more accurate. Now, before you distribute, combine the like terms. This is going to be 3, and we have inside these parentheses a positive x, and we have 3 plus 2, which is going to give us positive 5. So combine before you distribute. And over here we have x plus 1. All right, if it helps you, I'll do the brackets around this. In fact, that's how I should have done it to begin with. All right, it was x plus 1 times this whole thing. So in the brackets, we have x plus x. That's going to give us 2x. And we have 1 minus 1. That's just 0. All right, so I'll keep that as is. Now distributing. 3 times x and 3 times positive 5. And distributing x times 2x is 2x squared. And 1 times 2x is positive 2x. All right, so we have a quadratic because we have an x squared. We have to set it equal to 0. All right, since the x squared is already here, I'm going to get rid of this on the other side and make this side 0. Opposite of positive 3x is negative 3x. Opposite of positive 15 is negative 15. All right, so everything cancels on the left, and that's just 0. On the right, we have 2x squared. Positive 2 and negative 3 is negative 1. And we still have the x and minus 15. All right, I'm going to try to factor. And without getting into factoring by grouping, I think we can do it without it. All right, so we have a 2x. We're going to have 2 binomials. Since this is 2x squared, it's going to have to be 2x times x to make it 2x squared. And let's see, for the factors of negative 15, we have 3 and negative 5, or negative 3 and positive 5. All right, so let's see, you want them to add to negative 1. If I do 2 times negative 3 and 1 times 5, that would work. All right, so we have to use either of these two. I know it can also be 1 and negative 15 and so on, but I can tell already it's going to be one of these two. So let's try minus 3 and positive 5. All right, so 2x times x is 2x squared plus 5x minus 6x, because negative 3 times 2x is negative 6x. That'll give us the negative 1x. And 5 times negative 3 is negative 15. All right, anything times 0 equals 0. So either one of these can equal 0. So 2x plus 5 equals 0. And also x minus 3 equals 0. All right, negative 5 on both sides. Cancels here. 2x is going to equal negative 5. And dividing both sides by 2 cancels here. X is going to be negative 5 halves. On this side, I'm going to add 3 to both sides. 3 minus 3 is gone. Bring down the x. 0 plus 3 is 3. All right. Now, we might have to get rid of one of these, especially the negative one. Let me see if negative 5 halves would even work. All right. Yeah, it's not going to work. because negative 5/2 is going to be negative 2.5. Okay, if you put that in here, that means this length is going to be negative. Same with this length, same with this length. So there is no way negative 2.5 could work. Okay, but the other one, x equals 3, x equals positive 3, no matter where you plug it in, it's still positive. So that's the one I am going to stick with, x equals 3. Now that was a difficult problem because of the quadratic, not because of the geometry. It was difficult for the algebra. Okay, so alternatively, you could have used factoring by grouping, and you also could have used quadratic formula. But I saw the numbers aren't that big, so I saw what it would be without using either of those, just basic factoring. All right, if a secant segment and a tangent segment share an endpoint outside a circle, the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. All right, so this one here is the secant. See, it hits the circle twice. So same setup almost as last time. We have the external, that's EC, times the whole thing, which is ED, and that equals the tangent segment times itself. So it's basically EA times EA, or EA squared. Example 3, use the figure at the right to find RS. All right, so we just said a minute ago, take the external segment, so that's RS, times the entire segment, that's RT, and that's going to equal the tangent segment, RQ, times RQ, which is RQ squared. All right, and now we can just plug in the numbers. The external segment is X, so that's for RS. And that's times RT. The whole thing is going to be X plus 8, so you need parentheses. RQ squared is going to be 16 squared. Distributing, X times X is X squared. X times 8 is 8X. 16 squared is 256. All right, once again, we have a quadratic. It needs to be set equal to 0. So I am going to do the opposite of positive 256 on both sides. Cancels here, and we have this mess right here, x squared plus 8x minus 256. And that equals 0. All right. Now, we said a minute ago that 256 is 16 squared. Let's see. We're looking for two numbers that multiply to this and add to 8. So 16 times 16 definitely won't work. Let me see. If we do 8, okay, 256 divided by 8 is 32. That won't work. Let me see. All right, I'll try quadratic formula. This one is a little ridiculous here, but let's see. Negative b plus or minus radical b squared minus 4ac. And that whole thing is divided by 2a. Negative b is going to be negative 8. B squared is going to be 8 squared minus 4 times a, which is just 1, times C, which is negative 256. And that whole thing is divided by 2 times A, or 2 times 1. Phew, okay, let's see. Negative 8 plus or minus. I'm going to do this radical part on the calculator. And for the square root, I got 1088, and that whole thing is still divided by 2. All right, I am not going to try to simplify this because I don't want this problem to be too lengthy. I'm just going to round off. So we have negative 8, and for the square root of 1088, if I do the square root of 1088 and round it off to 1 decimal, I get 33.0. All right, so I'll just leave it as 33. All right, so negative 8 plus 33, that's going to be 25 over 2. And negative 8 minus 33 is going to be negative 41 over 2. Now, if you see in the drawing, x is a length, okay? So there is no way we can keep the negative answer. So 25 over 2 is the final answer. Or you can say 12.5. But that one was a pain in the neck. All right, so let's go back to what they asked us. And they actually wanted RS. Oh, so that was just X, okay. So yeah, 12.5 was the final answer for RS. And it looks like it's correct. So the answer makes sense.